Now, in this video, we are going to take up one more problem on projections of solids. How to analyze this problem and solve it by using the sketchbook. The problem reads as a pentagonal pyramid, 25 mm sides of base and 60 mm axis length, rests on HP on one of its edges of the base. Draw the projections of the pyramid when the axis is inclined to HP at 40 degrees and VP at 30 degrees. So here in this case, he has given the base of the pyramid and also the height of the pyramid, and also he says one of the axis is inclined at 40 degrees to HP and the axis which is inclined at 40 degrees to HP is also inclined at 30 degrees to VP. So that is the meaning of this. So first I want to start how to take the initial position. Since it is a pentagon, the side opposite will going to be a corner. So one side will going to be the edge and the other side will going to be the corner. So here, whether it is resting on HP on one of its edges or the corner, always you have to take the initial position such that one of the edges is perpendicular to VP. So to do that, first we will go for the initial position. So first here you can see one of the edge is perpendicular to VP. Which is the edge which is perpendicular to VP? AE. And the opposite is the corner. So that means this side is an edge and this end is a corner. Since it is a odd number size, that is the pentagon, so always the side opposite will always be a corner position. So here initially what I need to do, when you look from the top view, I can see all the sides which is AB, BC, CD, DE and EA. All these sides are parallel to HP. You can see all these sides are parallel to HP. Therefore, you can see the true length in HP. In this case, the true length of the side is the side of the pentagon, which is 25 mm. And since it is a pyramid, so we have an apex point. From the apex point, we are joining to the vertex of all these vertex points of the pentagon. So that means you have to join between O to A and O to B and O to C, O to D and O to E. All these edges are called the slant edges. Slant means which is inclined. You can see O dash, A dash, O dash, B dash, O dash, C dash and O dash, D dash and O dash, E dash. Now, if I look from the front, when you look from the top view, all the vertex points are visible. So A, B, C, D, E. And you can see O dash is near to the observer when you look from the top view. Therefore, O is visible and O1 will be invisible. Similarly, when you look from the front view, ABC is near to the observer. So A dash, B dash, C dash is visible. D and E is away from the observer. Therefore, D dash and E dash will be in bracket. Since O1 dash is at the center of the pentagon, O1 is at the center of the pentagon. Therefore, when you look from the front view, that O1 is hidden by the edge AB. Therefore, O1 dash will be in bracket. Now, how to write this manually now? First, we are going to draw the XY line and you mark VP and HP. Since one of the edges is resting on HP, so we need to start the problem from HP. So, the side which is resting on HP has to be perpendicular to VP. So, therefore, first what you do, you measure 25 mm and draw a vertical line and you mark that point as A here and E. So, by using the protractor with reference to the center point as A with respect to AE, you measure an angle of 108 degrees, which is the included angle of the pentagon, and draw an inclined line. Similarly, with E as center with respect to EA, you measure an angle of 108 degree and draw this inclined line. Then by using the compass, you measure the distance of 25 with A as center, cut an arc on this line. Similarly, with E as center, cut an arc on this line. Then from this point, you again measure an angle, take a radius of 25 and draw an arc here. And with this as center, cut on the previously drawn arc. So identify the point. You mark this point as B, you mark this point as C, and you mark this point as D. Then you take the midpoint of AE from C, you draw a line to the midpoint of AE with a thin line. Similarly, you take the midpoint of CD and with A as center, draw a line with a thin line to the midpoint of CD, so that these two lines will going to intersect at this point, and you mark that point as O and O1 in bracket. Then join O to A with a dark line, O to B with a dark line, O to C with a dark line, O to D with a dark line, and O to E with a dark line. Then you join A to B, B to C, C to D, D to E, E to A with a dark line. So this is how you will be able to write the pentagon. Since the height can be seen in the vertical plane, from XY line, you measure a distance of 60 mm and draw a horizontal thin line. Then draw a vertical projector from AE to the XY line. Similarly with O1 to the front view, and it is above the front view. Then from B and D, you draw a vertical projector to the XY line. Similarly from the point C, you draw a vertical projector to the XY line. As you look from the front view, ABC is visible, so A dash, B dash, C dash is visible, and you will mark them, and D and E is away from the observer, therefore you must keep it in bracket, D dash and E dash. Then, as you know, the height of the pyramid can be seen in the front view. So from this O1 dash line, you measure a distance of 60 and you mark this point, and you mark this point as O dash. Then join O dash to A dash, because visible to visible is visible, so you dot between O dash and A dash, and O dash B dash is also visible because O dash is a visible point and B dash is a visible point. So then join between O dash and B dash with a dark line. Similarly, O dash is a visible point and C dash is also a visible point, therefore you join between O dash C dash with a dark line. Then as we see AB and BC, A dash and B dash is visible. So visible to visible is visible, you dot between A dash and B dash, and B dash to C dash also, as B dash and C dash is both are visible points. Therefore from B dash also you draw a dark line. Then you join between O dash and O1 dash with a big dash and small dash line, big dash and small dash line with a thin line. So this is how you will be able to write the initial position of my pentagonal pyramid. Now, as he says, it is resting on one of the edges of the base, which is the edge which is resting on HP. The edge which is on the edge which is perpendicular to VP is the one which is resting on HP. So you know that since the edge A dash has to be on XY line, and since the base is on the left hand side, therefore you need to rotate this pyramid by an angle of 40 degrees with respect to XY line in the front view. So you take any convenient distance between the first position front view to the A dash A dash point, and you mark that point as A dash and E dash. By using the protractor, as we want to make this angle axis should be 40 degrees to HP, and then this and this axis line, the base of the pyramid and the axis line are mutually perpendicular, therefore you will going to get this angle as 90, and since the axis line has to be 40, so 90 plus 40 is 130, and this line A dash C dash should be at 180 minus 130 will give you the 50. So that means by using the protractor with reference to A dash A dash with respect to the XY line, you measure an angle of 50 degree with respect to the XY line. So then you will go to draw from A dash, you draw an inclined line, and this is the base of the pyramid. Now, as we know as we mark this line, you measure the distance from A dash to B dash using the compass. From A dash, you cut an arc on this inclined line. Similarly, you measure the distance from A dash to C dash with A dash as center, cut it on that 50 degree line. So you mark these points, that is B dash and C dash. Then similarly you measure the distance from A dash to O1 dash from the first position front view and transfer it from A dash on this to the baseline, and you mark this point as O1 dash in bracket. Now as we do that, then what I need to do, from this axis line you draw a perpendicular to this base by using the compass. With respect to O1 dash, you measure an angle of 90 degree. You measure an angle of 90 degree with respect to the A dash C dash line. Then you draw a perpendicular. Then you measure the distance from O1 dash to O dash by using the compass. From O1 dash, you cut an arc on this and you mark that point as O dash. Then join between O dash A dash, O dash B dash and O dash C dash with a dark line, and join between A dash C dash is also with a dark line. Then you join between O dash and O1 dash with a little bit thicker and with a big dash and small dash. Then this is how you will be able to write the second position front view by rotating the axis by an angle of 40 degrees to HP. Then to this I need to write the top view. How to write the top view? Draw a vertical projector from O dash and similarly from C dash and also from O1 dash to the projected point from OC and O1. So you will be able to mark this point as O, and you will be able to mark this position as O1 without bracket, let us say, consider, and draw with reference to that point here, C. You will go to get all these 3 points. Then draw a horizontal projector from both A and E, and draw a vertical projector from A dash and E dash. These 2 lines will going to intersect at these 2 points. You mark that point as A dash, top view A and E. Let us see then how this will going to become bracket. We will going to see at the later stage. And similarly, then draw a vertical projector from both B dash and D dash to the top view, and draw a horizontal projector from B and D. These 2 lines will going to intersect at these 2 points. You mark those 2 points as B and D, and here this is C, and since this is E and A, and this is O1 without bracket, let us see. Then once you do that, you join between A to B, B to C, C to D, D to E and E to A with a thin line. Don't dark them. Similarly, join between O to A, O to B, O to C, O to D and O to E. Once you do that with a thin line, now I need to write the visibility and invisibility. Here what the first condition of the visibility says, all the exterior edges of the boundaries of the solids are visible. Which is the exterior edges of the boundary? The extreme vertex points of all this pentagonal pyramid will go to form the boundary edges. So join between O to B, B to C, C to D, D to O with a dot line. Then the edge nearer to the observer is visible. Which is the edge which is near to the observer? As you look from the top view, O dash C dash is the slanted which is near to the observer. Therefore, you dot between O and C with a dot line. And here the boundary edges is already dot. Then the edge which is in XY line in the front view is always invisible in the top view. So if you see here, A dash and E dash in bracket, these 2 points is on XY line. As we look from the top view, this A dash, E dash will going to become invisible because all the surfaces are opaque. So here the edge, so what happens? Small a and small e. This is the one which I was telling in the earlier stage. So that means since A dash is on XY line, therefore both A and E will be in bracket. Then from a point, if any one of the edges is invisible, automatically all others edges from that point are invisible. What does it mean? If you consider AE is invisible. From this point A, you have two more edges which is going there. A to B, small a to B is the one edge, and O to small a is the another edge. Then O to E is the another edge, and E to D is the another edge. So what I want from a point, if any one of the edges is invisible, if you consider this point AE becomes invisible, that we know. So once this edge will going to become invisible, from this point A you have two more edges. One is small a to B and O to A. So since one of the edges, that is AE, is invisible, therefore automatically AB and OA will become invisible. Similarly, when you consider at the point E, here from this point E, you have EA is the edge which is invisible. From E, you have two more edges. One is O to E and the other one is D to E. So, since if one of the edges becomes invisible, automatically all other edges from that point becomes invisible. So, therefore, E to D will be a dotted line and O to E will also be dotted line. So, this is how you will be able to write. So, you have to keep this small a and small e. Since some of the edges of the pentagon is not visible, therefore, since O1 dash is on that surface, therefore, O1 will be in bracket. So, this is how you will be able to analyze and write the sketch for the second position top view. Now, the next condition is, as the axis becomes inclined to HP, what happens to the axis in the top view? So, this O1 will automatically becomes less than the height of the pyramid, that is O dash and O1 dash. So, O dash and O1 dash has got a height of 60. Then, since it is inclined to HP, therefore, what happens? It becomes, since it is inclined to HP, therefore, O1 will be in apparent length. Now, what I need, since the axis of the pyramid is the axis which is inclined to HP, O dash, O1 dash is the axis which is inclined to HP at 40 degrees. The same axis is inclined to BP at 30 degrees. Since you have the apparent length here, but the inclination given is true inclination, therefore, I cannot rewrite the same sketch on that 30 degree line. So, what I need to do, since the inclination given to the axis is 30 degrees, which is the true inclination, but what I have O1 in the second position top view is the apparent length. Therefore, I need to find out the apparent inclination here. So, how to do that? So, you consider any point with reference to the horizontal line, you measure an angle of 30 degrees and draw an inclined line, and you consider this point as small o. Then, since it is the true inclination line, so you have to take the true length of the axis of the pyramid. What is the true length of the axis of the pyramid? It is 60 mm. So, from this same point, you measure a distance of 60 by using the compass, cut it on that 30 degree line. Once you do that, then by using the scale with reference to this, you draw a horizontal line that will going to become the locus of O1. As we know, this is the apparent length. So, by using the compass with O as center, take the radius of O1 with the same center O, cut an arc on the locus line, and you mark that point as O1 in bracket. Then on this for beta inclination line, you start constructing this. So you measure the distance. So once you do that, then join between O1 and extended. So you measure the distance from O to C by using the compass. At the same point, you cut an arc on that beta inclination line. Then you measure the distance from O to this point and transfer it from O onto this line, that is the apparent inclination line. You mark that point. Now as we see, this line is perpendicular to this OC line. So what I need to do, with reference to this point, you take the protractor with reference to this point, which is on this AE line, and draw a perpendicular to OC or O1. Then from here you draw a perpendicular and extend it on either side. Then you measure the distance from this point to A and also from this point to A. Both will going to have the equal distances, and transfer by holding the compass at this point. You take that radius from this point to E and transfer it from this point onto that E. Similarly, you measure the distance from this point to A. From the same point, you mark it on this another line, which will be small letter A. Then, once you get this, then you measure the distance from O to this point and transfer it from O on that beta inclination line to here. Then, by using the protractor with reference to O1 line, with reference to this point, you draw a perpendicular to O1. Then, you measure the distance from this point to B and also from this point to D. Both will have equal distances, and transfer it from this point onto the left hand side on once and onto the right hand side. As we rotate it in clockwise, such that always the base should be nearer to the observer, though that is the very, very important case. Always you remember, whenever you are writing the solid, always in the third position, you make that base surface to be nearer to the observer. If you make that base surface near to the observer, the majority of the edges will going to be seen. So now here you join between O to B, O to C and O to D with a dark line, and join between O to E in bracket and also O to A in bracket. These two are invisible. Therefore, you join between O to E and O to A and A to B and E to D, and join between O to C. So this is all. You will be able to write the third position top view, here. Now, once you do that, now I need to write the front view. How to write the front view? Draw a vertical projector from O and draw a horizontal projector from O dash, and these two lines will going to intersect at this point. You mark that point as O dash, and draw a horizontal projector from C dash and draw a vertical projector from C. Both these two lines will going to intersect at this point. You mark that point as C dash, and draw a horizontal projector from both B dash and D dash, and draw a vertical projector from both B and D. These two lines will going to intersect at this line onto this B dash D dash line, and you mark that point as B dash and also D dash. Then you draw a horizontal projector from O1 dash and draw a vertical projector from O1, and these two lines or these 2 points will going to intersect at this point, and you mark that point as O1 dash for the time being. Then draw a vertical projector from both A and E to the XY line, because A dash in the second position front view, it is on XY line. Therefore, A dash and E dash will be on XY line. So you mark this between A dash, then B dash, then C dash, then D dash, and then E dash, and join from each of these vertex points to the apex point. That is O dash to A dash, O dash to B dash, O dash to C dash, O dash to D dash, and O dash to A dash. So this is how you will be. Of course, you have to join all these lines by means of a thin line. Then you apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. Which are all the exterior edges of the boundaries? O dash to A dash, it is on the boundary. You dark them. Then A dash to E dash, again it is the continuous line. Then join between E dash and D dash with a dark line. Similarly, join between D dash and C dash with a dark line. So then join between O dash and C dash with a dark line. So this is how you will be able to write the third position front view for the initial condition, that is the condition of visibility. All the exterior edges of the boundaries of the solids are visible. The next thing is the surface near to the observer. Which is the surface which is near to the observer? As you look from the front view, the bottom face of the pentagon becomes visible. Therefore, you join between A dash and B dash and B dash and C dash with a dark line. Now we can see the entire pentagonal surface is near to the observer. Then once you do that, then from a point, if two edges are visible, automatically the third edge also becomes visible. So what does it mean? From a point, that is from B dash, C dash is also the one of the edges, and similarly B dash, A dash is also one of the edges. Since A dash, B dash is A dash, B dash is the edge which is near to the observer, that is the entire pentagonal surface becomes visible. Then, as we see here from a point, that is two edges, that is B dash, A dash and B dash, C dash, both are visible. Therefore, from B dash you have the another edge which is B dash, O dash. So what happens? B dash, O dash will automatically becomes visible. Then the next condition is two visible edges can never cross each other. So what does it mean? So we have entire thing is being completed, but only the left out portion is O dash, A dash and O dash, D dash. As we see that O dash, A dash is the edge, when you are trying to join between these two, this line, that is O dash, A dash line, is crossing the visible edge. Therefore, two visible edges can never cross each other. Apply that rule. Since B dash, A dash, since O dash, A dash is the edge which is crossing on A dash, B dash, therefore O dash, A dash will going to become invisible. So you mark a dotted line between O dash and A dash. Similarly, apply the same condition from O dash, D dash. Therefore, you will going to get O dash, D dash will going to be in dotted line. Since the entire the pentagonal surface is visible, therefore, since O1 dash is on that entire pentagonal surface, therefore O1 dash will going to become visible. So this is how you will be able to analyze the problem and solve it by manually. How do I know that my problem is right? You can see here, even in the final position, one of the edges of the base of the pentagonal pyramid lies on HP. So you can see this entire line or the edge which is representing on XY line. Then the axis is inclined to VP, that is at 30 degrees. Since the same axis is inclined to HP at 40 degrees, therefore you need to find out the beta inclination line. On that beta inclination line, you will be able to write the you will be able to determine the angle, and since it is 30 degrees to VP, therefore you will going to get the apparent inclination. Why that apparent inclination is becoming here? Because the length what we get in the second position top view is in apparent length. Why this? Because the axis is inclined to HP. So you can see that. And since it is resting on one of the edges of the base, the base edge is A dash is on XY line, and it is also going evident from here where A dash is on the XY line. and the axis is becomes inclined to HP at 30 degrees. The same axis is inclined to VP at 30 degrees. Therefore, you need to find out the apparent inclination, which is beta. Then, this is a pentagonal surface of 25 mm side and a height of 60 mm is the pentagonal pyramid. So, this is how you will be able to analyze the problem completely and solve the same problem by using the sketchbook. Thank you.